talking about graphing simple, radical, not radical, rational functions. Okay. Let me scoot me a little bit further out of the way. Here we go. All right, let's get this started. So if you notice here, what is a rational function? Let's start with that. What exactly is a rational function? Well, what's the root word to rational function to begin with here, guys? Ratio. That's the root word, okay? Also known as a fraction, right? So what we're talking about, a rational function is a function that has a fraction, and not only that, it's got an x in the bottom, okay? And so that's what a rational function is, just in general. Hopefully, though, when you look down here, when we talk about our essential questions, how are the graphs of f of x with a 1 over x minus h and plus k, and this other f of x with the b there, how are they related to 1 over x? Well, number one, what we're going to have here is 1 over x is going to be our parent function, okay? Our parent function. That should be terminology we've used a few times now, right? You should be at least somewhat familiar with what a parent function is. Okay, and now check this out. Hopefully you've gotten familiar with this. This h and k thing's still hanging out here, isn't it? So this h, in now I know it's in the denominator. We're not used to seeing the denominator, but that's not. But that x minus h, that's that vertex form that we've talked about with several different other things. And so again, that x moves left and right, and that h, so that h is going to go left and right, opposite what it seems, because there's your opposite. And then over here, we got this k hanging out on the outside. That's going to move whatever shape it is up and down, just like it has with parabolas and with cubics and other things as well. That hasn't changed. And then this a in front, what in the world is that going to do? Well, that's going to stretch, compress the graph, okay? And then the 1 over b, same idea, except we're going to go sideways with those guys. More focused on the vertical. So let's do a little bit of quick history here. Okay, so hopefully you have the handout with the parent functions on it. We start off by talking about constants and linears and absolute values. And maybe you touched on what's called a step function, really, in algebra 1 or so. But then we've talked about quadratics, and that's really where we got real serious with absolute value and quadratics with the vertex form, talking about how that works, and it doesn't change. It's the same no matter what. And then we did it with cubics, okay? And then after we're done with what we're doing, we're going to go over to square roots and cube roots, which would be radicals, okay? So that's where we're headed to next. But where are we at right now? Well, where we at right now is these guys down here. It's called rationals, okay? And this is the main dude that we're looking at. Got cut off just a little bit there at the bottom. So I'll just add that in. This is f of x equals 1 over x. Now, some call this the reciprocal because it's just the x over 1 flipped over, which is a reciprocal. True. But this is a rational, okay? Rational function. And this is kind of a weird looking dude, isn't it? So we got two parts here. We got this little swervy thing going here, and this right here, hyperbola kind of looking thing. So that is what a rational generally looks like. And as it turns out, this guy over here next to it is also a rational. And even though it has definitely a different deal, but it's still, you can see how these two guys are related. They're both rational functions. But we're going to talk about this one right here, first of all, the parent function, 1 over x. So let me jump over here and take a little closer look at just it. Okay, so here's the two that we were looking at, the one on the left being the parent function, right? This would be our primary guy that we focus on everything we talk about, is that parent function. Now, and then we have this guy over here. And we'll bring him up here in just a minute. But right now, we're just looking at this one. So I wonder, when we were this graph, what caused these two pieces to have to curve like the way they did. What has caused that to happen? What has caused that? Well, first thing we're going to take note of is, look, the x is in the denominator. And what would happen if we were to use x equals 0? Well, bad stuff would happen, right? That would cause division by 0, undefined, and we're not allowed to do that. So what's kind of happened here is we have something we can't see. It's kind of what they call an asymptote, okay? asymptote, asymptote, okay? And it's kind of like an invisible force field. So that might help you out, because are we ever allowed to use x equals 0? Never can happen. So since x can never equal 0, that produces what's called a vertical asymptote. Asymptote. Okay. So since we can't use that, that's going to give us a vertical asymptote. Okay. Now, when it comes to rationals, we also have horizontal asymptotes, or maybe a diagonal asymptote. And that gets a little bit more complicated, and we're just talking about simple introductions at the moment. So we're not really going to go towards this direction, but just letting you know, they can get a little bit stranger in their shape, but they're still, you can tell there's definitely a relationship there. Okay, and the details I don't want to get off into at the moment, but just show you that there's lots of different things here. But so horizontal asymptotes happen as well, and different scenarios make that happen. But what always happens is anything that would cause the denominator 0 is going to help produce what's called a vertical asymptote, unless, like over here, what would we couldn't say, we'd say x cannot equal -1, because that would be bad, right? And there's that vertical asymptote. Don't get lost on me here, just saying. I just want you to know that there is an exception, slight exception to that rule, and that'll come later. So I don't want you to say, you make up your mind. We also notice that cannot equal, x cannot equal 2 as well, right? So why isn't there a vertical asymptote through the 2? Well, because these things canceled out. So what ends up happening here is we produce a hole. So we come along our graph, we get to 2, jump right over it, and keep going. So when this kind of situation happens, instead of getting a vertical line, we just put a little hole in the graph and keep rolling. That's another video for another time. I just want you to know that there's different things that happen with that. But our focus is, what causes this? Anything that would cause the denominator equals 0. That's bad, and we need to make some sort of exception to it. So we said we can't use 2, we can't use -1 over here. Can't use x equals 0. So what about the horizontal piece? Okay, well, let's talk about that a little bit. What causes that horizontal thing to do the same deal? Well, first of all, let's look at this idea here. Let's try some numbers, and maybe you can get a feel for what's happening. So what would happen if I did 1 over x? Well, if I put 100 in there, that would give me 0.01. What if I put 1,000 in the denominator? 0.001. Okay, what if I put 10,000? 0.0001. Okay, so the higher my x value gets, the smaller my y value is. Will my y ever make it to 0 though? Nope, sure won't. My y will never ever make it to 0. Okay, because so you see here, as it thing gets closer and closer to y equals 0, it kind of stalls out, doesn't it? And that's kind of where the horizontal thing's coming from. But let me get back here and finish the job before we. What if we come from the other side? Maybe that's how you have to do this. Well, okay, well, let's go from the negative side. Well, all that does is give us -0.01 and -0.001 and -0.001. It's never going to make it to 0. Okay, so the idea comes from is this. So as you come from this way, you're going to get closer and closer to 0, but never make it. As you come from this direction, you're going to get closer and closer to y equals 0, never going to make it. So that produces our horizontal asymptote. And that's just a feature of having an x in the denominator. That's just kind of what comes to the territory there. Okay. So this is our parent function, and parent function is what we compare everything else to. Okay. Whew. Well, a couple more observations I want to make while we're here is we talked just a second ago about how this relates back to what we talked about from the very beginning. X minus h moving things left and right, and the k moving things up and down. I'm not going to be overly worried about the a at this point. But these two guys, because we're still talking about the simple stuff. What about the parent function? What value is h and k on the parent function? Well, let's help you out here. This is -0, is it not? Then plus 0. So what does that mean? That means h is equal to 0 and k is also equal to 0. Okay? Because they're not there, right? But lo and behold, look at these asymptotes. Where do the asymptotes cross? At h and k. That's our vertex. It's not really a vertex, right? It's where the asymptotes cross. That's where the two force fields cross, right? And so that's how we're going to know where to put our asymptotes. Okay? Is it where it would make the denominator 0 and then this guy up here when it's in the vertex format, right? So when it's set up like that, that's how we're going to know how that works. Okay. So there's those dudes. All right. So here's this guy here. We've decided that we got this 0 and 0 thing, and that's where we got our vertical and horizontal asymptotes. But how do we know where to graph the rest of it? Just like you always do, start plugging in points using your table. So here's, they plugged into -1 and -0.5, and these are deals and did them over here. So our job now is, first, always, we graph our asymptotes, okay? That's what we're gonna put in. We're gonna graph those asymptotes. And after we do that, we start plugging in some points here, plotting points. So let me get to look here. So -2, -0.5, right there. -1, -1, and -0.5, -2. So we play connect the dot here. That's supposed to be blue. What's going on? Let's just make those blue. I usually like to make my asymptotes red. No rule, just kind of always is done that way. And so then that gives me some good points there to make some decisions on. It's important to have those points. So let's go ahead and try these other spot here. So that's 0.5, 2, 1, 1, and 2.5. And again, that sets us up for being able to draw in the rest of our graph. Okay, so first thing again, your vertical asymptote is what makes the denominator 0. Your horizontal is 0 unless there's something else on the outside that's pushing it up or down, right? In this case, it stays 0. But how do I know where to draw this thing? Because if I didn't graph some of these points, how would I know whether this thing comes in really, really tight or comes in really, really loose? You don't. That's why you got to graph this actual points, plot the points. Go to table, plot points. That's how you graph stuff. Never changed that, have I? From day one. Plug in, go to table, plot points, play connect the dot. Okay? How many points you do till it looks right. And in this case, you have to plot points so that you know what shape the curve is. Okay? So that's what you kind of got going there. Asymptotes, plot points, play connect the dot. Yay. Oh, there's one more thing we have to do when we're looking at these guys. Well, the asymptotes already put that in there. We can label our asymptotes. Okay. And so that's a prettier graph. Come over here. So here's our asymptotes. We got a VA for vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. We've already established that. So this is what a good graphing thing would be. You would have some good points. You would note here your vertical and horizontal asymptotes, making some notes on what you got. All right, so that's all the introduction to the simple. Let's do That's another section there. Okay, this is what, okay. Let's take a look at this example. I've already got the parent function in place in blue, okay? And in green, I have an example function that we're going to practice through, okay? Now, a couple of things. Let's make some observations. What would make our denominator 0? 1. So x in this case cannot equal 1, right? Can't equal 1. All right, so that's one thing we know. That's also what's going to happen here is our horizontal asymptote is going to move over. Sure enough. Check this out. Because what does this mean? Oops. What does this mean right here? What's that mean? And if that was a parabola, what would you say? Well, x's go left and right, and so -1 makes you think left, right? But it's really the opposite. It's to the right one. So we would say this is right 1 unit, right? And then what would this guy here say? Well, see, the outside's always up and down, right? Outside's always up and down. So this would shift up 2 units, right? Is that what that 2 is going to do for us? What's about crazy 3? Well, I'm not overly worried about. We're just going to plot points to manage the 3, basically. But this would be a what? A stretch of factor of 3? Stretch by a factor of 3. So it's going to take our parent function and kind of stretch it out. Because just think, if you grab the top arrow and the bottom arrow and started pulling it like that, wouldn't that thin it out a little bit? That's kind of what's going to happen. So, all right, first thing I always said, we said to do what? Graph your asymptotes first. Okay, so what we're going to do is we're going to take our parent function right here, and we're going to shift our asymptote. If I can get that baby to do right, yep, there it is. We're going to shift that guy over 1 unit to the right. Okay, and then what are we going to do to the horizontal? What's that say? Shift up 2. So I'm going to take my horizontal and I'm going to shift it up 1, 2 units. Okay, and so you see where it crosses now? Over 1, up 2, kind of our vertex, because it's in vertex form, even though it's not really a vertex, it's just where they cross. Okay, and so what's that going to do to the rest of my graph? Well, let's get this guy. If the 3 was not in front, what that would do is that would take this guy up here and just drop it right in here. Bam. And then what about these guys? All right, and it shifted right up in here. Okay, but the 3 is there. Okay, so but before we do that though, but what happened from the parent function? Everything went to the right one and up 2. But now what we're going to end up having to do, okay, is we're going to have to grab a hold of this guy right here and stretch it up. Okay, and we're going to have to grab this guy right here and stretch it down. So because of that, what we're going to do is give me just a second. Let's get rid of all these other things here and let's just plug in some points. I think that'll be a better choice because if it weren't for the 3, we'd basically be done. But the 3 is there, so we can't ignore it, right? We can't ignore the 3 there. So let's do what we're going to need to do for that. So there's all the parent function stuff disappearing on us. We got our asymptotes in place. So that's what we do first. And then I took the parent function and kind of shifted it over to show you how that would go with it. But since it's stretched, we're going to need to actually go through and plug in some of the points for that, okay? We're going to need to plug in some of those exact points. Let me grab my calculator here, go to my table, okay? Ooh. All right, so I see on my table it says 1 error. Well, that's because the asymptote there, 1 comma error. Then I got 0, -1, so 0, -1. Is that what it says? Let's make sure I'm doing the right one. Yes, okay. 0, -1. So 0, -1. I'm doing this in green, so we know which one we're talking about. And then I have -1.5. So -1.5 positive. Okay. Then it says -2, negative, +1. And then -3, 1.25. Okay, I think I got the pattern going now. So it's coming up here and heading that way. And then that dude is going to kind of match it coming down. Okay, so that's one side. Am I done? No, we got another side over here to go. So let's go down here to 2, 5. So over 2, up 5. Over 3, up 3.5. 4, 3. So over 3, over 4, up to 3. 5, 2.75. And 6, 2.6. Starts slowing down a lot, doesn't it? It doesn't change a lot. So I think now that's not changing a whole lot. I think we can just finish this guy out. And there you go. All right, so we've been talking about graphing simple rational expressions. So we introduced the concept of what is an rational function, and that's just a function that has a fraction, but the x is in the denominator. And because of that, we're going to have these vertical asymptotes, and then horizontal or diagonal asymptotes depending on the situation. And then if it's in vertex form like these simple ones, we're just going to take our asymptotes from the parent function situation and shift them left and right and up and down, and then graph some points. Fill her in, how many points? Well, enough points till you get the right kind of deal, because you want to make sure you get the turn in the right spot. Hope that's helpful. Have a good day.